Hello, my name is Bryonna and I'm a software engineering major from Team 12 of the 2023 Computer Science and Software Engineering Senior Design Projects. Today, I will be summarizing the 2D motion analysis / training lab software system. To begin, let's talk about the ACL. The ACL is the anterior cruciate ligament. It connects the femur and the tibia and is commonly injured by athletes. Despite this injury's high rate of occurrence, there are few accepted ways to pre-screen for an ACL injury. Our industry mentor, Dr. Yi Eliza Wu, wants to change that. Her research focuses on the female ACL and its risk of injury, particularly because athletes assigned female at birth are more likely to sustain an ACL injury. To complete her research, the industry mentor needs several software and hardware components. This project's goal is to combine as many components as possible in an effort to make her workflow more intuitive, while also implementing the key formulas and algorithms that she has derived during her research. Essentially, this project's main outcome is to have a desktop application for biomechanical analysis that is built off of an existing open-source video annotation software and also includes custom features such as a streamlined UI, task automation, and Dr. Wu's formulas for calibration and calculation. However, there is a second component to this project as well, an interactive educational application. This component started as a game-like application for data visualization, but it quickly became clear that making a game that incorporates ACL information and culminates in a quiz would be the best way to go about engaging a K-12 audience. So now, I will move on to giving a brief demo of the first system within this project, which we have been calling the analysis system. This is what you'll see if you open up our analysis system. It has a much more simple UI that is specifically tailored to the use case of the training lab portion of this project's title. This streamlined UI was designed for ease of use, ease of picking it up and going, so that instead of demoing it in an office, it could be taken outside on the go and have athletes video themselves so that they can track it and assess their risk. So now, what we want to do is graph the position in the horizontal and vertical axes. So we'll hit graph position. After tracking all 12 points and loading the video with the 12 points so that it creates a horizontal and vertical position for each point, you can use the graph position button to graph the position. The first one that comes up is horizontal position. Skipping ahead a little bit, now after clicking save to file and use immediately on horizontal position, you are automatically given vertical position. From there, you can again save to file and use immediately, and that will sound off in the back end that now you want to complete calculations to find the moment on each tracked point. And then once the analysis system has completed all of the calibration and calculations on the 12 leg points, which are all formulas derived by Dr. Wu and implemented in the system by Team 12, us, it will present you with two graphs. The first one has the first 6 markers, and the second one has the second 6 markers, as it is separated by tibia and femur. And these graphs show the moment versus horizontal position. There are other things that can be graphed. However, the formulas that we were provided by our industry mentor are still in progress. While this project is complete for us and our team, and we do have a second part that we completed, our project is not entirely functional for the industry mentor's use case yet, because the research that she is doing to make these calculations and get the formulas that we need is not entirely complete yet. And with that, I will now hand over control to my teammate Colin, who will demo the secondary system that we have created for this senior design project.
Thanks, Bryonna. My name is Colin and I'm a computer science major. I'll be showing the second component of our project, the interaction system, or what we just call the game. Our goal for the game is to inform a middle and high school aged audience about the importance of joint and mobility health, good form, and specifically ACL injury risk and prevention. To achieve this goal, it must be engaging for the target audience and keep their attention, while still containing enough educational material to be able to pass the knowledge check at the end. The premise of the game is that the player has sustained a minor injury to their ACL and is taken to the hospital. At the hospital is the X-ray minigame. It allows players to explore the internal structure of their legs, simplified to the major bones and ligaments, and separated to each leg for visual clarity, but still showing how everything fits together. When the player clicks on a body part, a message appears identifying what it is. The player can also choose to ask the doctor questions in order to learn more. After recovering in the hospital, the player begins physical therapy to gain their strength back and to learn more about preventing future injuries. Shown is one of several planned minigames that would cover the rehabilitation period. Finally, the player returns home to mom and dad, who mercilessly grill her about everything she's learned. Don't worry, I won't spoil all the answers. It is called the interaction system, not the watch and learn system. This brings us to the end of the game and our project. Thank you very much for watching from Team 12.